Hello class, welcome back to another section of our calculus course. In this class, we're going to talk about bound sets. If this is your first time visiting this class, kindly press the subscribe button and turn on the notification button to get updated of all the classes as well as the next classes I'll be posting. Kindly watch this video to the end. There's an interesting concept in calculus. So let's see what this video has for us. In this video, I'm going to consider upper bound, lower bound, then the boson-Weierstrass theorem with some examples. So let's see what it is. Whenever I have a set, and let's say X is a member of a set A, and if in this set there is a particular number M which is less than or equal to X, and there is another particular number which is capital M which is greater than or equal to X, then we say that the set A is bounded. I come again. X is a member of a set A, and if this set has a particular number M so that S is greater than or equal to on the left side, and also has a particular capital M so that it is greater than or equal to X, then we say that this set A is bounded. Then this M I have here is what we call the lower bound. Then the sets here, this number here is what we call the upper bound of the sets. All that this means is, in that set, there is a particular number which is M, so that no number will go beyond on the left side, and there is a particular number, capital M, so that no number will go beyond on the upper side. That is upper bound and lower bound. Let's see boson-Weierstrass theorem. What is boson-Weierstrass says? It says every bounded infinite set has at least one limit point. So boson-Weierstrass theorem is saying that every bounded infinite set has at least one limit point. The key terms are bounded, then infinite. When you say it is bounded, meaning it has one point of the section of the set which all other number can cross. And when we're talking about boundaries, negative infinity and positive infinity are unbounded and they are not included. So if you have a set and one part of the set has positive or negative infinity, that set is said to be unbounded. It can have a half bounded, but if the two sides are negative and positive, then it is fully unbounded. So first of all, let's take this example. Have close 0, 1. This is an interval, and it consists of a lot, infinite number of sets, which we can list them from 0 to 1. We can have infinite. But when you look here, we have a number 0, we have a number 1. This 0 is smaller than 1, yes, and it represents our small m here, and this 1 represents our bigger m here. We can say that 0 is the lower bound and 1 is the upper bound, in that no number in this interval will ever cross 0 on the left side, no number in the interval will ever cross 1 on the right side. So that is bounded and non. That is lower and upper bound. And what Bosano is saying is, if you have a set like this, it should have at least one limit point, yes. So let's see if 0 can be a limit point of this set. If I take 0, I'll take any neighborhood, let's say 0.5. Therefore, my neighborhood will be 0 minus 0.5, comma, and go brackets 0 plus 0.5 point. Now it should be used to solving neighborhoods. So this will be negative 0.5, then 0.5. So in this interval, which is the neighborhood, we should get members of this set within. In this member, or in this interval, we have 0 to 1. Here is negative 0.5 to 0.5. Surely, members of this set will fall here. Therefore, 0 is said to be a limit point. Hence, Bolzano-Weierstrass theorem holds and is true. Let's see this another example I have here. I have 1 out of 2, 1 out of 3, 1 out of 4. It will go 1 out of 5, 1 out of 6 to infinity. Now, this set is said to be half bounded here, 1, but this side is not bounded. And Bolzano's theorem is saying that if you have an infinite bounded, yes, it's bounded on this side, then you should have at least a single limit point. So therefore, let's choose 0 as this limit point also. We can see that these numbers are converging to 0. We can have 1 out of 200 and something and they all converge to 0. So if I take 0.5 neighborhood in this neighborhood like this, you can see we'll have these numbers falling here. 1 out of 3 or 4 here, all of them will fall here. Hence 0 is also the limit point of this set. Hence Bolzano-Weierstrass theorem holds. This is all I have for you in this video. I'll be posting the tutorial questions later in this class. Don't forget to subscribe and like this video as well. Thank you.